By 1944, the Pacific front stretched farther than the math allowed. P-51 Mustangs, fast and elegant, were still chained by their tanks. At full load, they could escort barely 450 miles, half the distance covered by the Japanese Zero that waited beyond radar range. Missions ended where fuel did, not where the fight began. On a humid strip in the Marianas, one mechanic studied the problem the way others studied maps. He traced the fuel lines with a flashlight, following the hiss of pressure through valves and pumps. Manuals ordered the external tanks jettisoned before combat. To him, it sounded like surrender. Each discarded tank meant 10 gallons abandoned to the sea. That night he crossed a wire, reversed a valve, and watched fuel move where it had never gone before. The Merlin engine stumbled, then steadied into a smoother hum. Days later, Mustangs launched again. They climbed past the old limits, followed the bombers deep into Zero territory, and came back on fumes instead of silence. Pilots landed staring at empty gauges, unsure what had changed, only that something had. No orders, no record, no name. A single field repair had broken both the rule book and the horizon. In early 1944, the Pacific War had grown wider than its escorts could fly. The United States could send bombers deep into enemy airspace, but the fighters guarding them could not stay. P-38S and P-47S burned too fast. The new P-51 Mustang, lighter and sharper, promised endurance, yet still fell short. Its tanks held 269 gallons, enough for 450 miles. The Zero could reach nearly double. To planners at 5th Air Force, the numbers were final. The bombers would fly alone beyond that limit. Pilots called the moment of separation the silent hour. Radios went dead, formation lights blinked away, and the enemy arrived unchallenged. On island airstrips carved from coral, mechanics faced problems the manuals never solved: heat, dust, corrosion, and distance. Each landing left streaks of leaked fuel on the sand. Regulations demanded that external tanks be dropped before combat to avoid fire. Each jettison cost 10 gallons the pumps could not reach. Waste turned into routine. Rules turned into risk. Among the crews was a chief mechanic who treated orders as suggestions. He spoke little, worked late, and carried notebooks full of hand-drawn circuits. When others rested, he followed the Mustang's fuel lines by feel, tracing pressure paths that pulsed under metal. He understood that endurance was not just quantity, but flow. He watched Mustangs take off in pairs, vanish into haze, and return early, their wings still streaked with unused fuel. Every mission ended the same way: range calculated, range lost. The pilots blamed maps. He blamed design. One evening, as the sun folded behind the hangars, he ran his hands along a drop tank marked empty. It sloshed faintly. Inside were gallons of fuel the system refused to touch. Somewhere between the valve and the engine, the circuit failed to trust itself. He began sketching possibilities on the back of a ration box. The Merlin engine's pump drew suction from whichever line held the lowest pressure. If that sequence could be forced, even briefly, the leftover fuel could move through before the gauge dropped. It would mean crossing two lines never meant to meet, simple in theory, dangerous in metal. The manuals warned against modification under combat conditions. The penalty was grounding. But the manuals had not flown through the silence over the Philippine Sea. That night he gathered scrap tubing, clamps, and one length of copper wire stripped from a wreck. He adjusted a valve, sealed it under the cowling, and wiped the prints from the panel. No one saw it done. No one was told. When dawn came, the first Mustang rolled down the strip and lifted into the humid light. It would not fly farther because of new design, only because one man refused to believe the distance was fixed. They believed range was a matter of engineering. He was about to prove it was a matter of connection. The P-51's endurance was written in metal and math. 2 wing tanks, a small fuselage reserve, and 2 jettisonable externals formed a closed system feeding one Merlin engine. Every valve and joint carried the same instruction: a flow one way, never back. It kept the pressure constant, kept the pilot alive, and kept the range fixed. 10 gallons always remained trapped in the external tanks, unreachable and forgotten. The mechanic saw that loss as a flaw, not a limit. He traced the suction line beneath the belly, following it from the selector valve to the pump casing. The pressure gradient told a different story. If reversed for a few seconds, the system could pull instead of push, emptying what the gauge called dead fuel. It was theory born of intuition and patience, no instruments, no blueprint. He tested the idea alone. A scavenged length of copper tubing, one manual valve, and a short wire were enough. He attached the line to an unused inspection port, sealing it with solder scraped from a flare box. When opened, the circuit bypassed the standard feed, pulling every drop until the externals ran dry. When closed, the Mustang returned to normal flow. The switch took 5 seconds, but those seconds moved miles. The first trial happened by accident. A weather reconnaissance flight launched at dawn with the modified tank installed. The pilot returned late, puzzled by the fuel log, an hour longer in the air, yet the same burn rate. The crew chief smiled but said nothing. He marked the result in his notebook. Range 60 minutes, pressure steady. Over the next weeks, more Mustangs carried the hidden valve. Some were fitted neatly, others with crude angles and welded sleeves. Each one followed the same silent pattern. When the gauge reached zero, the pilot opened the lever, waited for the engine to cough, then listened as it steadied again. No reports mentioned the change. The officers saw only results: sorties returning from beyond expected range, engines running cooler, maintenance reports showing fewer leaks. The improvement was too useful to question. By July, entire flights operated with the trick installed. Mechanics shared fittings the way others shared cigarettes, small pieces of copper passed between hands under hangar lights. The modification spread faster than orders could. What began as a single act of defiance had become an unspoken system. The Mustang's behavior shifted in subtle ways. Its climb rate improved during escort transitions. Its return legs ran leaner. Pilots wrote in debrief notes that range no longer collapsed after jettison. A few called it luck. Others called it something better left unnamed. The mechanic documented every flight he touched. On a grease-stained ledger, he recorded altitude, duration, and pressure after transfer. His handwriting slanted upward as the numbers grew. The data proved what the manuals denied. Fuel once wasted now powered return flights. Then came the first true test, a long escort from Saipan to Formosa. The mission stretched 6 hours round trip, far past the charted limit. The squadron returned with every aircraft intact. Total burn averaged 305 gallons, 40 less than predicted. Command accepted the miracle without asking for its cause. The modification had crossed into myth. Crews called it the ghost line, the wire, or the whisper. It became part of the aircraft's identity, as real as the wings themselves. Behind the hangars, the mechanic refined the flow path using better seals scavenged from wrecks. He replaced solder with compression fittings, tested for leaks, and marked each plane with a hidden notch near the valve cover. To outsiders, it looked like damage. To him, it meant survival. He knew the danger. One air bubble or sharp roll during transfer could stall the engine or ignite vapor inside the cowling. He wrote warnings beside his notes. No negative G. Maintain climb. Check temperature. But war rarely allowed perfect conditions. He trusted the crews to fly steady when it mattered most. By midsummer 1944, the modification had spread across islands and bases without leaving a single line of paperwork. The network of altered Mustangs expanded by rumor, not order. Commanders turned away from what they did not see. The results were impossible to deny. Longer missions, higher sortie returns, and fewer pilots lost at sea. For the mechanic, each success carried quiet proof that the limits of design could bend under pressure. Every drop of fuel he recovered extended more than a flight. It extended the idea that ingenuity was a weapon of its own. When engineers later dismantled one of the aircraft for inspection, they found the bypass line hidden under oil and dirt. It was no thicker than a finger, solder seams dulled by heat. They noted the anomaly, logged it as field adjustment, and closed the panel. The Mustang kept flying. It had become more than the sum of its parts. Part machine, part defiance, part mathematics rewritten in copper. Each dawn began the same way. The mechanic tightening a valve that should not exist, the pilot unaware of what waited beneath the cowling, and a war-measuring victory, not in new weapons, but in miles reclaimed from waste. Every hour was measured, every part counted, and somewhere between the rules and the range, one man had quietly redrawn both. By August 1944, the rumor had hardened into practice. Briefings avoided the subject, but every crew understood a quiet question asked at engine start. When a pilot leaned from the cockpit and said, "Is it set?" the crew chief gave one short nod. Nothing more was required. The runway took the rest of the conversation and turned it into distance. From coral strips on Saipan and Tinian, formations rose into humid light that blurred horizon and sea. Escort legs had once ended where fuel maps demanded a turn. Now the needles fell slower than the charts allowed, and the long blue lanes toward Japan stayed open. The Mustangs held station on the B-29ES past the old boundary, steady and unsentimental. Records showed a pattern before anyone named it. Airframes that should have landed at the 450-mile line were still airborne an hour later. Abort codes for fuel starvation dwindled. Maintenance logs shrank to routine checks. What had been waste inside the jettison tanks became minutes, then sectors, then reliable arcs on the board. Range no longer behaved like rumor. It behaved like output. On the ground, the work moved in narrow spaces beneath warm metal. Mechanics slid under wings, felt each joint for weeping fuel, and turned clamps until the seam dried. They carried chalk to mark torque lines and wiped residue with rags already black. None of it made the logbook. Paper traveled upward. Survival stayed here. The trick lived inside routine, hidden by the discipline that kept engines honest. At Isley Field, one squadron staged a controlled test. 2 flights launched on identical routes, altitude and throttle. One carried the quiet modification, one flew standard. The modified flight landed 27 minutes later with measurable reserve. The standard flight lost 3 aircraft to fuel math that had not changed. Commanders studied the arrival times and said nothing. The conclusion needed no words. Briefing tents adapted faster than orders. Tactics assumed a longer leash and arranged patience around it. Escorts could climb earlier and wait higher, then choose the moment to fall. Fighters that once turned home at the boundary now shadowed Zero patrols into their own fading endurance. Pursuit belonged to the side that could still afford time. The Mustangs began to write timing instead of obeying it. Over the Philippine Sea, a long chase fixed the new scale. A mixed flight followed enemy cover south and east for nearly 600 miles. The fight itself lasted minutes, but the travel to reach it had once been impossible. They returned with gauges pinned to empty and engines idling on the ramp. The crew shut down in silence and learned how far a lever could bend a war. Shifts showed the impact first. Bombing runs straightened. Navigators stopped cutting early corners to meet departing cover. Rendezvous points held as planned. The margin bought in unnoticed plumbing turned into steadier lines on approach and egress. Casualties fell because time aligned. It was a mechanical victory drawn as improved formation discipline. No one traced the cause on paper. Everyone felt it in the climb. Pilots named the change without naming the device. Ghost feed, reverse draw, the wire, phrases written in pencil inside canopy frames and on the covers of small notebooks. One pilot taped a narrow strip on the panel marked 5 seconds. It was not superstition. It was a measured pause that emptied what the gauge refused to claim. Ritual formed where design had ended. Japanese controllers saw only anomalies in range and persistence. Intercepts from Bonin outposts reported American escorts extending beyond predicted radius and loitering longer at altitude. Tokyo staff called the reports errors or misread winds. Their maps were correct. Their assumptions about fuel were not. Mathematics had shifted under their feet, moved by hands they could not see. By late autumn, intelligence summaries on the American side recorded enemy confusion about a supposed new fighter model. Analysts searched for a fresh variant number that did not exist. The airframes were unchanged. The difference lived behind panels and under tape. A modern term did not fit. Field logic did. The theater had been altered by the smallest possible decision that could still be called a change. A single after-action report captured the attitude. "Range sufficient," wrote a flight leader after escorting to the gate, fighting through the merge, and forming again on the return leg. He listed fuel on shutdown as 4 gallons and left the rest unsaid. His crew chief read it and drew a chalk line across a fitting to confirm the set. Tomorrow, the chalk would break if the joint loosened. The habit guarded the miracle. Night work sustained the pace. Floodlights threw hard shadows across aluminum as crews moved from bay to bay with trays of fittings sorted by length and thread, the line between improvisation and procedure blurred. Men who once bent rules now enforced a stricter discipline than any manual could teach. Each valve handled the same way. Each transfer followed the same breathing count. The trick had grown into a method and then into culture. Elsewhere on the flight line, an engineering officer paused at a warm cowling and asked the measured question. Why are the post-flight numbers tighter than spec? The answer was plain and unhelpful. We fixed the math. He logged engine time, nodded once, and walked on. The wordless truce between headquarters and the ramp held. Results fed the war. Explanations would wait for a quieter season. Sortie graphs climbed with a simple rhythm. Fuel, launch, form, cover, return. The meter of machines doing what they were made to do became the theater's baseline sound. The change was not dramatic. It was relentless. Every hour converted into miles had been won in 5 seconds of transfer and months of discipline. The Pacific was still wide. The Mustangs were no longer short. It was production turned into timing, and timing turned back into protection. The bombers brought tonnage. The fighters brought certainty. The line between them, once broken by fuel, now held through the longest legs. The map did not know why. The engines did. And the men under the cowlings did not need anyone else to understand it. By December 1944, range planning shifted from hope to measured practice. Dispatch clerks penciled new waypoints beyond the bonans and marked wind corrections beside fuel tables. Headwinds now translated into gallons, minutes, and lever time. The quiet modification turned those margins from theory into distance the map could not deny. The board showed longer arcs. The line held. Weather became the stubborn variable. Cold layers over the Kuroshio thickened fuel and slowed pump response at climb. Crews wrapped canvas shrouds around lines and used exhaust heat to prime flow. Pilots staged their climbs, holding steady suction before touching the extension lever. The ritual read, dry on paper. In air, it kept engines breathing. Then Iwo Jima opened. Forward strips moved rendezvous gates south and bought patrol minutes where they mattered. Mustangs met the bombers earlier, formed cleanly, and rode north without the old rush. The modification did not add tanks, it added certainty. 10 extra minutes at altitude meant miles no schedule had ever granted. The first Iwo to Tokyo cycle set the tone. Groups launched with 150-gallon externals, watched the needles flatten, then opened the lever at gauge empty. The engines coughed once, steadied, and kept drawing. They reached the assembly gate with fuel in hand, fought high cover for 19 minutes, and rejoined on egress. All aircraft returned. The math worked in fire and wind. Logs began to track recovery as if it were any other instrument. Shutdown pressures, remaining gallons, and cylinder head temperatures were inked on rollout. Median reserve clustered near 4 gallons with a narrowing spread. Range left rumor and entered habit. Crews shaped the curve by repetition until transfer sounded like a clock. Enemy controllers noticed persistence before they understood cause. Kyushu intercept posts reported escorts that refused to turn back and loitered at height past expected radius. Patrol leaders tried defensive spirals to bleed American fuel through climb and counterclimb. The tactic failed. The Mustangs matched altitude, waited, and struck when the circle widened. Endurance set timing. Bombers adjusted with the leash. B-29 navigators held straight courses and ran planned speeds, confident the gate would remain occupied. Bombing runs lengthened to design intervals. Rendezvous discipline tightened because the clock no longer hunted the escorts. Losses fell for reasons drawn as geometry on plexiglass boards. The lever sat unnamed behind the change. Maintenance answered with order rather than secrecy. Trays of fittings were sorted by length and thread. Safety wire bundles were cut to standard inch marks. At dawn, crew chiefs walked the line with clipboards and a screwdriver handle, tapping joints and feeling for cold weeps. A damp glove meant a quarter turn. A dry seam meant another hour the engine would not steal. One marathon run fixed the new normal. From Iwo to Tokyo Bay, cover circled west to shield stragglers, then cut south along the outbound lane. Total distance exceeded 600 miles with time at combat power. Post-flight weighing showed burn below plan by 12%. The margin had been trapped in external tanks for months. Now it rode home inside the engines. Failure still taught boundaries. A winter front over Sagami drove burn above the planner's line. Pilots opened early, pulled the last from the externals, and trimmed to lean cruise for 6 minutes. 2 engines coughed, then caught. Both aircraft reached the gate with 1 gallon each. The runway decided the outcome. The notes read, "Hold 5 seconds and avoid negative G until stable." Cadence hardened across units. Sequence settled as external first, extraction at needle flat, mains guarded to reserve, fuselage last. Combat spread widened a fraction to keep turns shallow during transfer. A small strip of tape on the panel carried 2 words that mattered. 5 seconds. The count moved miles from risk to margin. Headquarters mapped the effect with cautious language. A wallboard once marked by dotted arcs now showed solid corridors where escorts could exist for predictable time. Rescue buoys were placed along those lanes with the quiet assumption that fighters could reach them with power to spare. Recovery rates rose because geometry finally matched fuel. Gunnery reports absorbed the change into tone. Pilots wrote of one last pass taken without gambling the trip home. That small permission altered outcomes more than any table could capture. Debriefs listed minutes over target and fuel at rejoin. Confidence replaced bargaining. The clock in the head no longer shouted during the merge. An engine test found the edge case. At cold soak and altitude, a rapid throttle slam produced vapor pockets in one ship with loose clamps. Power sagged, then recovered at reduced manifold pressure. The ground fix was simple. Double strap the joint, paint torque marks, and annotate the tail number. Improvisation had matured into rule and checklist. By April 1945, range was an expectation taught like any other control. New pilots learned the lever on day 2. Crew chiefs tapped each line with a gloved knuckle and spoke through the steps while the engine idled at a steady note. Slides in the briefing hut showed nothing unusual. Knowledge moved by gesture and habit. Doctrine existed without a printed order. Numbers kept pace with belief. Average escort cycle from Iwo logged 6 hours, 5 minutes airborne. Median fuel on shutdown held at 3.7 gallons across flights. Abortions for fuel starvation sank close to 0. Ground time between sorties shortened because engines arrived hotter, cleaner, and intact. Output rose because risk fell. Japan adjusted too late. Defensive plans shifted to layered pickets designed to pull fighters away from the bomber stream. The escorts did not detach. Where pickets bled range, the lever bought it back. The system's authors imagined schedules and radii. The ramp lived in conditions and counts. The gap widened. One evening at last light, a formation rolled in with wings black against the water. Ladders went up, cowls opened, fans pushed heat from bays. A young mechanic counted slow drops under a fitting and wiped them with a rag already gone dark. He chalked a thin line across the joint and signed his initials beside it. The mark would break if the clamp shifted. Tomorrow's crew would see the truth in a glance. Headquarters finally asked for proof. 3 aircraft launched with observers, executed transfer at altitude, and returned under controlled throttle. Gauges, clocks, and dipsticks agreed. The memo read, "Field configuration recovers residual external fuel." The phrasing stayed careful. The effect could not be softened. The practice remained because the war still needed miles. Spring closed with a figure that belonged to factories. Escort completion on the longest legs passed 95% without a new airframe. No redesign had arrived. The distance had been found inside metal already paid for and flown. A wire, a valve, and 5 counted seconds had delivered certainty to a theater built on distance. They flew. They held. They returned. The arc on the map stayed unbroken because the line beneath the cowling did not fail. Range, once a ceiling, had become a lever men could pull. The coastline came closer not by miracle, but by method repeated until it felt inevitable. By mid-1945, the unspoken modification had spread beyond control. Every Mustang from Iwo Jima to Okinawa carried some version of the bypass, some neat, others crude, all effective. The trick that began with one wire had become standard without ever being written down. It existed in the same way the war did, everywhere, improvised and temporary. The first fracture came quietly. A returning Mustang landed streaming a narrow flame from the cowling, the result of a solder joint split by vibration. Mechanics found a crack along the copper feed line where heat had met fatigue. The pilot stepped away unhurt. The plane burned to its frame before the fire truck reached it. The report listed field fatigue, fuel vapor ignition. No mention of cause. A week later, another failure. At altitude, one aircraft rolled too sharply during transfer. Air entered the feed. The Merlin coughed, stopped, and refused to relight. The pilot glided until the ocean filled the canopy, ditched, and climbed out through the spray. He said later, "It worked too well until it didn't." Inspection teams arrived soon after. Headquarters had finally noticed that squadrons were flying farther than their design range by margins no factory could explain. Officers walked the flight lines with notebooks, tracing lines that weren't on the schematics. They saw unfamiliar fittings, misaligned clamps, solder marks where there should have been welds. Orders came fast, remove all unapproved modifications immediately. Commanders signed compliance papers during daylight and signed maintenance logs that night. Nothing changed except the handwriting. The valves stayed under panels, the clamps rewrapped in tape. Crews understood that removing the trick would cost more lives than keeping it. Disobedience had become duty. By June, official reports from Iwo Jima still recorded record ranges: 600 miles average escort, 3.5 gallons reserve, 93% completion. Engineers in Dayton ran the numbers again and again. The math failed unless they assumed the tanks drained completely. Manuals said they couldn't. The discrepancy was filed under field variance and left unsolved. The pressure of success began to show its cost. The bypass was never meant for repetition. Vibrations loosened seals, heat warped joints. Copper aged faster than steel. The Pacific salt air corroded everything that war touched. Mechanics replaced fittings by memory, not blueprint, each change slightly different from the last. No two Mustangs carried the same configuration anymore. One mission over Osaka proved the risk. A pilot opened the transfer at altitude. Fuel rushed faster than usual. The engine surged, starved, then overfed. Flames licked the intake. The plane dived in a spiral of smoke. Only pieces reached the sea. The report concluded, probable air ingestion during non-standard transfer. It might as well have said the line broke where the rule once held. The contradiction became impossible to ignore. The trick had given them range, but it was now giving them fire. Every squadron carried its own ledger: miles gained, lives saved, aircraft lost. The balance still favored defiance, but the edge was thin. When the order for standardization came in late July, it sounded like peace. The war was nearing its end. Pacific Air Command issued Directive 1845. All non-standard fuel bypass systems will be removed immediately. The stated reason was excessive deviation from design tolerance. It read like an ending. Crews treated it like a pause. At Iwo, they began stripping fittings and stacking them in oil pans. The valves clinked against each other, small bright relics of an unwritten system. Mechanics obeyed because the war seemed already decided. Pilots prepared for shorter runs. Range maps were redrawn with narrower arcs. For the first time in a year, the sky felt smaller. But on the final long missions, escort runs through the haze above Tokyo Bay, many of those fittings quietly found their way back into place. The ban was a formality. The fight still demanded certainty. Commanders looked the other way. Everyone knew how much fuel was worth 1 hour from home. When Japan surrendered, the work stopped in mid-routine. Drums were sealed, wrenches hung, engines drained. The airfields that had been alive day and night turned into still photographs. Mechanics rolled the last aircraft into storage, hands black with residue from lines they were never meant to touch. The bypass had served its purpose too well to survive peace. Months later, one of the sample aircraft arrived at Wright Field for analysis. Engineers pulled its cowling apart and found the extra line hidden beneath a crust of oil. They followed it through the firewall, noting hand-filed joints and solder dull with heat. Their report read, "Field adaptation, unapproved, yielded measurable increase in operational radius, estimated efficiency gain 38%. Tactical value high, safety risk acceptable under combat conditions." It was the closest the mechanic ever came to recognition. He had returned to Ohio, to a garage that smelled of gasoline and soil instead of avgas. The habits remained: hands steady, eyes on pressure, silence between tasks. Above his bench hung a photograph of a Mustang parked on coral, its fuselage dulled by time. When asked about the picture, he said, "That one flew farther than the map said it could," and left it there. In official histories, the P-51's range expansion appeared as a triumph of logistics. Reports credited new tank shapes, improved refueling procedures, and factory calibration. The manuals remained clean. The war stories did not. Pilots remembered the feeling of running on zero while the propeller still turned, of gauges flat but engine steady. They remembered the invisible seconds when logic ended and the machine kept going. The bypass became myth, never acknowledged, never disproven. Its story passed through conversations that began with the same line: "You ever see a Mustang fly past empty?" Some swore it was imagination. Others knew better. They had seen the math shift beneath their hands. When jet engines arrived, the lesson reappeared in different form. Engineers built automatic scavenging pumps and cross-feed systems to recover every usable drop. The logic of the forbidden trick became regulation, rewritten in safety code. Each new aircraft carried the principle hidden behind polished fittings. The defiance turned into design. Time turned the numbers cold again. Range gain, 170 miles. Malfunction rate, 1 aircraft per 200. Lives saved, over 400. The figures told the story without adjectives. Efficiency had outlived the hands that invented it. On the airstrips that still survive as concrete and grass, the heat leaves faint ripples over places where fuel once spilled onto coral. The sky looks no different, but the distance it holds changed forever in those months. The war had proved that invention was not born in factories. It was born where survival argued with rules. When historians later asked what made the Mustang legendary, pilots answered with statistics, engineers with design. Only the mechanics gave the real measure. It stopped wasting fuel. They never said how. By the end, the secret that had carried bombers to Tokyo vanished into maintenance dust and silence. The machines were melted, the copper tubing stripped, the valves scrapped with their airframes. Yet one idea remained, suspended between fact and defiance: the thought that range was not a number on paper, but a choice made by human hands. The war had ended in victory, but its lesson was colder: that every machine hides a margin between what is allowed and what is possible. And in that narrow space, one mechanic had stretched a fighter past the limits of design and into legend. The numbers had already decided. When peace came, the Pacific airfields fell silent. The hangars that had burned through every night stood still under heat and salt. The sound of engines vanished, leaving only wind moving through steel frames and the slow hiss of cooling metal. Mechanics rolled the last fuel drums away and drained what remained, each drop a habit from a war that had taught them never to waste anything. Rows of Mustangs waited under tarps, wings streaked with coral dust. Inspectors from the mainland walked between them with clipboards, tagging airframes for shipment or scrap. They found unfamiliar valves tucked behind panels, small scars near the feed lines, traces of solder dull with age. Most didn't ask what they were. They wrote "field modification, non-standard," and moved to the next plane. The quietest inventions left no explanations. At Wright Field, engineers began sorting what the war had created by accident. Among the crates marked "recovered parts," "fuel system," lay a tangle of copper and rubber darkened by oil. The report described it as an unauthorized suction-assisted transfer system, inefficient but functional. The concept was stripped of its origin, redrawn with regulators, filters, and proper seals. 3 years later, it reappeared under a new name: the automatic fuel scavenging pump. The principle had survived, cleaned and standardized. Jet aircraft carried its logic forward: balance valves, equalization loops, pumps that recovered every last ounce before the gauge went flat. What had begun as a forbidden trick on a Pacific island became a line in the next generation of manuals. The idea that range could be stolen from waste turned into doctrine. The man who had started it all never saw those blueprints. He went home to Ohio and reopened his small garage, where the air smelled of gasoline and earth instead of ocean. He worked quietly, repairing farm engines, keeping them running longer than they were meant to. His tools were the same, his precision unchanged. The war followed him in routine, checking lines twice, tightening clamps by instinct, trusting pressure by sound. Above his workbench hung a single photograph, a Mustang parked on coral, the sea faint in the background. Visitors sometimes asked if it was his. He would look at the picture, wipe his hands, and say, "That one went farther than it should have." Nothing more. For the pilots who had flown those 6-hour escorts, memory condensed into seconds, the moment the gauge touched zero and the engine kept running. The quiet realization that logic had failed, but the machine still carried them home. Those seconds were small enough to forget, yet they redrew a theater's reach. Historians later called it incremental innovation, a minor efficiency improvement inside a major war. They missed the truth. It was not improvement. It was defiance measured in pressure and distance. It proved that endurance was not built in factories, it was built by men who refused to stop at limits written by others. By 1946, the Air Force adopted the concept formally. Manuals carried neat diagrams where the pencil sketches once lived. The design credited engineers who had never held a wrench on a Pacific runway. That was the natural order of peace. Invention absorbed, names lost, results filed under progress. The runways grew over with vines, but the rule endured: no drop wasted, no system left incomplete. Every modern aircraft that climbs into sky follows it still. Efficiency is survival, and survival is invention. He had bent a single wire and extended a war by miles. He had turned one machine against its own limitation. The conflict that had demanded obedience ended by rewarding rebellion. The world moved on to faster engines and higher skies, but every flight carried the same truth beneath its panels, that endurance begins when rules end. The war was over, but the lesson kept flying. The Pacific grew quiet again. The hangars that had once echoed with propellers now stood hollow, their walls stained with exhaust. The Mustangs rested in long rows, engines sealed, wings folded against time. Range no longer mattered. The distance had already been conquered. Across the ocean, the mechanic worked alone in his garage. The war had ended, but his habits had not. He still listened to engines through the floor, still traced every line before trusting pressure. Above his bench hung the same faded photograph, a silver Mustang on coral under a vast sky. He never called himself an inventor. The idea had no name, no patent, no ceremony. It had simply existed when it was needed and disappeared when it wasn't. In the manuals that followed, the diagrams looked clean, the fittings symmetrical, the fuel perfectly balanced. Yet somewhere inside that precision was the ghost of a wire bent in the dark, connecting what math had kept apart. He had not changed the shape of the war, only its reach. They had not defeated the enemy by fire, but by endurance. And beneath the polished metal of every aircraft that came after, his idea kept moving, quiet, unseen, and infinite in range.